In Chapter 7, we're going to review some techniques that we can use in making decisions on projects for corporations. So we're really looking at corporate decision making. Which project should a company do when they're provided with a set of projects to choose from? So we're going to talk about different techniques. There are several of them out there that we'll talk about. We're going to talk about the decision rules for each one of those techniques. We're going to look at cash flows, try to determine between choices, right? If there are more than one project to pick from, which project should we choose? We're going to look at comparing these competitive tools. We're going to discuss why the internal rate of return can give a flawed decision. And in the end, we're going to also discuss what's referred to as the profitability index and why sometimes it might not be able to make a good decision for us or might not provide the right decision. So let's first talk about, remember a little bit about net present value. This is a very simple formula. It assumes cash flows that last forever. So this is what we refer to in the time value context as a perpetuity. And it has a very simple formula. It's just the cash flow divided by the interest rate. So if you're going to spend $2,000 and you're going to receive $500 a year forever, what rate of return do you earn on that investment? Or what is its net present value if you know the rate of return on that investment? So if we take a project from your textbook, there is a project it's this Fredrick's Fertilizer project. We plug in the information, we find that if the cost of capital was 17%, the net present value is $941. And they should obviously do this project because net present value is positive. Now what this table is, this is what's referred to as a data table. And if you input in this table, the upper right hand corner here is the formula for net present value. And this column represents changing or plugging in a different number. For R here, let's change that number, calculate net present value, and then find the value and graph that. So here we have this graph. It's what's referred to as a net present value profile. So at 17%, the value is $941. It's right there. At 11%, it's $2,545, right? What is it at 25%? At 25%, the net present value is 0. What if it was 31%? 31%, we'd have a negative $387 is the value of this project. It's this net present value. So we have here a guide that can tell us, at what cost of financing, right? At what required return would this project create value for the company? And any rate of return that has a value that's less than this 25%, or any cost of financing that's less than 25%, would increase the value of the company. So let's think about some other alternatives besides net present value, right? Sometimes they'll give us the same answer, but sometimes there will be conflicts, right? So when the rules conflict with each other, net present value should always be followed. Why is that true? Net present value measures the change in wealth of the company that's expected if the project is implemented and the cash flows actually occur. So one of the first techniques we can talk about is something called the internal rate of return, right? Any investment where the internal rate of return exceeds the cost of capital is a good project. right? So if it's going to cost you 12% to buy the project, but the project's going to return you 15%, 15 is better than 12, you would want to do the project. The investment rule will give you the same answer as net present value in many, but not all situations. In general, the internal rate of return rule works for standalone projects if all of the project's negative cash flows precede its positive cash flows. Right? So in your text, there's a picture, right? Whenever the cost of capital is below the internal rate of return of 14% for that picture, then the project has a net present value, has a positive net present value. You should undertake that investment. So if we go back here, right, at zero, the cost of financing is 20%. There's no value to the company if you do a project and this project and it costs 25%. But if it costs anything less than 25%, you are gaining and increasing value to the company. So what happens, or what are the situations where net present value and the internal rate of return disagree with each other, right? So what can happen? And there are three primary instances where this happens. Delayed investments, we have times when there just are no answers. There's no internal rate of return that you can find. And then there are times when we'll have multiple internal rate of returns. That is, there's more than one return that's possible given the formulas that we talk about. So the first one, we have the first pitfall that they talk about is what happens is we have a delayed investment, right? So a publisher offers you $1 million today. You're going to spend 3 years writing a book. The problem is you're not allowed to do anything else except write that book. What happens, though, is every year you could have received $500,000 a year from speaking engagements. So what is the cost, right? What is the value to this person of going ahead and taking this $1 million and writing the book? We're going to use the capital budgeting techniques worksheet. So if you plug this numbers into the worksheet, one of the things, the first thing you'll see is these are some different examples where you're going to receive money up front. And I'm sure you realize that in most projects, that's not the way it happens. So this says it should be negative, but let's not worry about negative. You're going to receive $1,000, so that's positive, and you're going to give up the $500 a year for 3 years. What is the value of this project? The net present value is negative $243, right? So should you do this project or shouldn't you do this project? Well, if you look at the internal rate of return, it says that you'd actually receive a return of 23% on this money. And again, we only had a 10% opportunity cost. So you're getting over double the opportunity cost. The challenge is it's the internal rate of return, right? Percentages are funny things. You have to ask yourself, percentage of what, right? In this case, if you were to go along with this publishing deal, you would actually reduce your total wealth by $250,000, $243,000 odd. Even though you made 23%, you lost value. Okay? Which is more important, dollars or percentage? If you actually look at this formula or this net present value, it shows that net present value is an increasing function of the discount rate. And that just doesn't make sense. The discount rate represents the cost of financing. It includes a risk concept. That risk is included in the cost of financing. So as risks go up, you expect to have higher discount rates, not lower discount rates. And when discount rates go up, values always go down. What about multiple internal rates of return? Again, this case, they're going to offer us $550,000 in advance. And then over the next 4 years, we're going to get cash flows. And then we're going to get $100,000, we're going to get $1 million in 4 years when the book is published. Should we accept this project? Well, again, when you plug these numbers in, we get $550,000 up front. We get that $1 million at the end of the 4th year. And if you graph this relationship, you'll see that it is this curvilinear shape that crosses the x-axis twice. So there are 2 times where the internal rate of return is possible. Having 2 answers or having more than one answer is not what we want. We want one answer and one answer alone. It turns out that every time the cash flow sign changes, there is mathematically one possible answer. So we got 550, that was a positive number. We also had lost some cash flows for 3 years. That's a negative cash flow. So it changed one time, but then we also received another $1 million. So now the cash flow changed a 3rd time. So it actually changed from positive to negative and then negative to positive. So that gives us these 2 potential answers. So it's possible that the internal rate of return can give us 2 answers. In addition, it's possible that it could give us no answer. Again, if we got $600,000 in advance, then there would be no internal rate of return that we could find for this example, right? So there's no answer to the question. And I think the overall rule here, the overall purpose of this discussion is just to realize that the internal rate of return rule has some shortcomings. It's very popular. People understand percentages more than they understand net present values. The challenge is we have to ask another question when you talk about percentages. And that question is, percentage of what? Would you rather have 10% of 1,000 or 10% of 1,000,000? They're both 10%, so you should be equally happy with both of them. But I suspect that you wouldn't be. If we have to choose between projects, we need to know something about those projects. Projects that are competing with each other are referred to as mutually exclusive projects. When you choose only one from amongst several, this choice is what's referred to as mutually exclusive. It implies a ranking mechanism. So we have to rank projects from the highest net present value to the lowest net present value. And of course, we always select the project with the highest net present value. Now remember, if you select the project with the highest internal rate of return, you might not be maximizing the value of the company. You might not be generating the highest firm value for the owners of the company. And which would they want? Would they want a higher rate of return, or would they want more wealth? So that's the end of part 1 of chapter 7.